Symposium. As Karen mentioned, we are three colleagues from HDR. We have Wassem Hawary from the Los Angeles office, Timothy Halvorson from San Francisco, and myself, Argelia Barcena from the San Francisco office. And today, this is going to be a three-part presentation. We will talk to you, and you will hear different perspectives. Our experience varies from 2 years of professional experience all the way to 18 years. And also from BIM with Revit to computation and design and computation on a day-to-day use. So with that, I'm going to get started with our presentation. The title is We're Building Information Modeling That Meets Computational Design. HDR has more than 10,000 employees, and it's both an architecture and engineering firm. We have offices in different countries with more than 225 of them. So I am going to start the presentation talking about BIM best practices and workflow. Wassem is going to talk about day-to-day computational use, and Timothy is going to talk about leveraging computation and design.
And just as a basis, just to understand the differences between BIM, because this has been focused on BIM and what computation really is. It's not like we're CAD, where BIM kind of pushed CAD to the side and became a different thing. They're actually complementary and they enhance each other. So in short, BIM is kind of the stuff or the elements, and computation is the thread that connects those elements and allows you to do the precision filtering and manipulations, different generative modeling, creating really robust rule-based systems that you may have seen in other workshops today. And then BIM, obviously, is modeling the information, the documentation, the kind of hard deliverable stuff. But they're in a symbiotic relationship. So we'll talk about both.
A little bio on ourselves. So I am the digital practice office leader in the San Francisco office. I also teach as adjunct faculty at San Francisco City College. So just our credentials. Wassem is digital practice office leader at HDR in the Los Angeles office. And Timothy has computational design as his specialty and also a designer. So from here, I am going to, my case study. The case study that I'm going to focus in on will be a medical campus, 400,000 square foot. And the outcome of this presentation for you is to just talk to you about the workflow that we implemented in a multi-building project on the same site. It entails, decisions that we had to take as far as the size of this project, people working from different offices, different office locations, and it was a team of more than 20 people. So how do we make all of that work? The project scope was a renovation of a 2-story building plus the addition of 2 new 4-story buildings, and they all connected to each other. So we had 4 Revit models just for the architecture part. We started with the core and shell, then the existing building, and new building 1, new building 2. In addition to all of this, we had the consultants and other disciplines also with the Revit models. And with the exception of the civil engineer who used AutoCAD. This is a layout of the building. So we have the existing in the middle, and the green area was the renovation. 1 on the left is one of the new buildings, and then 2 on the other side. The letters here represent the typical sectors in which the building had to be divided. So as you can see, we had a lot of them, and in order to fit them on a single sheet of 30 by 42, we had to separate them like this. In addition to these typical floors, in the basement, there were also 2 more sectors that we needed to add. So some key decisions that were made as far as documentation, right? The first thing that you have to take into account is, are we going to separate the models, or are we going to put all the models in one file? So we went with separating the models. After that, you have the decision of how are you going to issue the sheets. Are they going to be approach 1, in which each model will host its own sheets, or approach 2, in which the host model will have all the sheets for all the buildings, right? In this case, we consulted with the team and with the project architect. It was the project architect's decision that he wanted all the sheets in the same model, so that you didn't have to go back and forth. The benefit of this was that everything is in one location. The benefit of the other approach was that you have everything in the same model, but I'm going to speak a little bit more about that in detail. The other decision was, are we going to issue this as a whole set of drawings or a combined set of drawings? So these are decisions in the beginning that you have to take into account in order to manage your models. The decision was to have a core and shell package and then a tenant improvement interior architecture. The graphic here represents the graphic here represents each of the models that we had. So building 1, 2, existing building, and core and shell. And the host model we decided was going to be the existing building. So within the existing building, we have the sheets for each of those 3 buildings. And then the core and shell has the sheets for just the core and shell package. The decision that we made proved to be good in a way that everything was in one single location, right? But when you were faced with a moment with a deadline and you see that something is wrong in a drawing, and that is not in the host model, you have to go open the linked model, fix it, reload it in the host, right? So that was the bad part of it. But overall, I think we made the right decision. So from that, you go into work sets. In work sets, once you decided what models you have in your project, these are the things that made us decide how we're going to move forward with work sets. So Revit links, how many Revit links do you have? Right? Are you going to create one for each model, or are you going to have just a Revit links work set? Or one for mechanical, one for electrical, etc. The next one was CAD links. So we only had one CAD link, which was the site plan, which was good. And then grids. We needed a work set for the grids because since each model was going to have grids, it was very important for us to separate those. After that, we have internal disciplines. So within HDR, we also have an equipment team. So they were doing the medical equipment, and they also had their own model. So how do you deal with those? And after that, you have to set the naming conventions for your work sets so it doesn't become a mess and not everybody's creating whatever they want in the work sets. Lastly, assigning ownership. I'll give you an example. We had existing grid lines and new grid lines. It happened a lot that the existing grid lines were being moved around by accident. So in that case, I decided to take ownership of the grid lines, and I did not release them unless I left for a day, came back. And that fixed the issue because that prevented people to be moving them around. And they're set, if they're existing, they shouldn't be moved around. And these are just examples of the work sets that we had. So there's good and bad in each of these, okay? We started with our plan of work sets, but then more and more got added. So I'll start with the first one, in which we see equipment ceiling, and equipment minor. So equipment ceiling, we didn't see the need for separating ceiling from equipment in itself. So this is an example of, you can minimize them into a single work set. You don't need the 3 of them. As far as the grids, we needed work sets for each of the grids because in this case, DNT was the core and shell. Existing was existing. North and South Tower were the other 2 buildings. So we needed a way to control the grids individually. We had one for the CAD, one for electrical, one for mechanical, and then the rest of the Revit links were combined into links Revit. In this first image, we see a model management work set, but then if you go to the second image, it says file management, right? So here somebody went in there and created a work set for the same purpose, but named it differently. So we have to be careful of these things and make sure you're setting naming conventions. This takes us to the copy monitoring of levels and grid lines. Again, because we have so many models, you have to decide on which model will be the master of the grid lines and the levels, because they're all sharing the same levels and the same grid lines for the core and shell. When somebody moves a grid line, right, there's a change. There has to be a movement only in one model, and then the other models follow it. So that's what copy monitoring does. It'll copy monitor them throughout, and so we use that. And also our consultants use that to copy monitor their grids to match ours. Then the next item on the list is the work sets colors to easily distinguish one from the other. So when you're trying to see what belongs in what work set, in such a big project, it can be difficult. Right, so let me just go to the next slide quickly to show you. This shows, the purple shows the architecture work set, and then the red shows the existing grid lines, and the green shows the new grid lines. So this way we could easily distinguish, okay, if items are on the wrong work set, or if somebody cannot find something on a drawing, you know, where is it? You turn on everything and you can see what's in the right location and what's not. Back to the other slide, distinguishing and controllability of existing grid lines versus new grid lines. So this is locking, what I was talking about, locking the work set so you control it. You create a separate work set for the existing grids and a separate one for your new ones. And then the grid bubble shape. So we created a different shape for the existing to make it easy for the team to distinguish. Again, the work set and the ownership. Next was the views. So now we're getting further into documentation and when you're creating the sheets. You have views. For example, a room, you have elevations. Right? Are you going to create those views in the individual models and then link those into the host? Or are you creating those in the host model altogether, right? And if you create them in the individual models, are you going to annotate them in there? Or are you going to annotate them in the host model? So we learned a lesson here. We opted for annotating them in the individual models and then linking that view. The lesson that we learned was, if you are annotating or dimensioning, I should say, dimensioning something in a linked model, and for some reason an element moves or gets deleted, the dimension goes away, anything that's referencing that disappears. And you don't know what it is, because when you first open the model, it'll give you a warning that, you know, so many dimensions disappeared, but you don't know which ones. We learned the hard way. We were dimensioning to grid lines in the individual models, and because those grid lines were turned off in the host model, those dimensions were disappearing. So we did a hybrid in which dimensioning for the blue shows the linked model, and you see the blue dimensions. They're coming from the linked model, right? But anything that's dimensioned to a grid line was done in the host. That way, no grid lines were disappearing on us. The room tags were done in the linked models as well. Yes, so we had grid lines from the linked models, and we created reference planes that we could snap to and then lock to the grid line so they would move with them. So what I'm trying to say here is you have 3 different options, right, of annotating. One is not necessarily better than the other one, but it's a matter of you picking what's better, picking your battle, right? Are you willing to lose this benefit over the other? It's also a pain to have to go back to the linked model to fix something when you're on a sheet on the host. So it's a matter of preference, but we learned the pros and cons of each of them. And we decided again to use linked views in the view templates. And by linked views, I mean the overrides for the Revit links have to be unchecked in the view templates because you want to be able to control those individually per view. So once you get into the window of the Revit link, you click on the by linked view and you browse to the specific view that you want to be shown on that sheet. Right, so this means that in your linked model, everything is annotated perfectly, graphically, it looks as nice as it could look, and it's ready to be put into the sheet. So that's when you go by linked view, identify it, and it pops in, just like you want it to look. And from here, I just wanted to also mention that a lot of this takes, annotating, adding door tags, adding room tags. It can be a long process in Revit if you have a really big file. So then we have add-ins and plugins, other platforms that can be used in conjunction with Revit that will help with the process and make it easier, streamline the whole process. And that's where Wassem is going to step in and talk about that.
Hi everyone. So I am going to talk about the computation aspect of that you would use in documentation. So our whole presentation was literally split into 3 parts, which is basically a day of our life at HDR. The person who used BIM as just the basic platforms, not using any computation side of it, and a person who uses it a little bit of a computation to push and expedite some of the production work, and a person use it in a design and flexing more of the skin and the shape of the building. So I had this belief since I was in my bachelor degree that there is no such a thing that a program can do everything, and just you have to get the right aspect from each program to link them together and move through platforms to get the final kind of result or achievement that you desire with the easiest way possible. So I'm going to have a couple of case words that I'm using different platforms to achieve a kind of an expedited less of my time, more of the machine time to create what it's supposed to do, right? The machine's supposed to do all of the heavy lifting and I'm supposed to just relax and think. So this example is basically a room renumbering. And room renumbering involves a lot of human errors. If you have a large-scale project, then you need to go to each room and number it, and then if the planning has changed, then you have to remove the room and then renumber the whole thing, and it's really painful process. And it could put you kind of asleep when you're doing it. So this baseline or the room renumbering process, you need to have a couple of steps, right? You would determine what is your end product. What do you want it to number? Which way you want it to number? Do you have a pattern that you want to follow? Do you have a process? Do you have an algorithm that I want it to jump from 1 to 3 to then 6, or do you have some kind of algorithm to use it? So this is determining the end product. I want to renumber it from a 100 to 132, jumping one number, skipping one number in each room. And this line, the red line, is basically the way that the Revit or Dynamo will pick up and renumber the whole plan. So understanding what is the room basically, and how Dynamo would pick up a room and how would it think of that room. So if you are familiar with Revit, when you drop a room by automatic room in Revit, then it will put a center line and a center dot in the center of the room. And that's where basically Dynamo will pick up and say, okay, so this is the center point of this room. I'm gonna run a line and have approximate who is the closest to this line from left to right, and then basically stream kind of a sorting list, and then take it from that to renumbering the whole plan through that line. So from there you can have this view that would show you that my curve now is really controlling where the number is gonna start using Dynamo, and I can literally take that curve, which is a model curve, and move it and change the way that renumbering the whole thing, or rerun the script if we have removed a room or changed anything in the planning aside. So now I literally took 2 days of work and shrink it to a 30-second or a 40-second of opening Dynamo, running the script, renumbering the whole project in no time. So this is the Dynamo Revit script. Basically, Revit is picking up, Dynamo is picking up all the center point, and then taking the curve, and then approximate the closest point to that curve and sorting it by order, and then renumbering the groups. So this is kind of thinking that if we already have rooms, and we already have a project, we already have a plan that we need to renumber. What if we don't have any rooms? We're just starting a project, we have a program, and we want to streamline all the massing. So again, it is a process that will take a heavy lifting. You need to do an X, Y, and Z, and then lay out all your rooms to give it to the planner, who then will play with it as a Lego and then put the building together. So instead of doing that manually, we literally can use Dynamo again. So this is an Excel sheet that has all the room data, all the information, all the area that we are expecting. Run it through Dynamo. Dynamo literally take it and put a massing, and then you are done. You have a full building with massing in, again, no time. If you have a new project, you update the Excel sheet, you run the script, you have a new tools to give it to the planner. So this will be my second example. And here I used Rhino, Grasshopper, and then Revit and Enscape to render it. And in this process, I want to show a little bit of a different thing. I'm going a little bit onto the interior design. Sometimes we have those perforated metal or something that you want to design, but you don't have to really model. Like, you don't have to model everything to get it out. I mean, you can use the simplest way possible to achieve the output that you want as a look or as a design. So what is the plan here? So basically determining what is the pattern that I want to use in the middle panel. And here we had an agricultural project, and we took this image from Google Earth, and we said, you know what, we're gonna have a perforated metal that kind of reflecting the Google Earth map on a panels, okay? Then what do we do next? So taking the image, put it in Grasshopper, and then Grasshopper basically gonna take the image, rasterize it, and put a dot that is arranged between 1/4 of an inch to 3/4 of an inch, depending on how dark is that image. Basically, it will stream out a circles in Rhino. Then we would take it to Photoshop. I don't have to use the modeling. I just used Grasshopper literally to create a Photoshop image. Taking it from Photoshop to Revit, put it as a cutoff, and now I have a panel that is in 3D, that has perforated metal, and I didn't have to have all those heavy circles in 3D in Revit that might crash the project, might affect the workflow of the whole project, right? And in the end, we have a rendering. So the green in the back is an installation for sound, and the panel in front is Revit, and it's using the dots from Photoshop as a cutoff to cut the whole wall and ceiling. Okay, so last example. So in here, I didn't use Revit. We had design options. We want to do literally a curtain wall options in terms of patterns, in terms of size, and doing it in Revit didn't make sense at that time. This is almost like 3 years old. So it's quite outdated, but for me, it gave me a little bit of a more push to use it in other projects. So taking this to Rhino, literally having the panels to be kind of basically randomized. And instead of changing the glass, we said, let's change the glass reflection. I am not gonna use a lot of glass type. I'm gonna use 4 glass types, the yellow and the red and the blue and the green. And each one has a little bit of a different reflectivity that would result in something like this, where you wouldn't really find where is the patient room, even though they are vertical and horizontal, and just a little bit to play with your visual to kind of take you off that regular pattern. And you can do something like this, where the difference between the two images is literally 30 seconds again, because I'm using Grasshopper to animate the dimensions, the heights of the mullions, and then the reflectivity, and run it into 3D Max and V-Ray. And those whole three cases that I explained is a little bit of using small amount of computation. I didn't use all a lot. I just used a little bit that to achieve that process and kind of give more profit to the company, because I don't have to spend weeks on changing notebook numbering or the panels or studying. But then we have more of an experienced use of computation, where you use actually to really flex the skin and change some of the properties of the building, and Tim will take you there.
Wassem, do you guys want to step over here? Everybody, is this good if I talk like this? Yeah. Pretty good? How's everybody doing? Good. Okay. It's like we're all falling asleep. Last one, right? Wow, we're cruising. Okay. I'm gonna talk about a very specific project that I worked on actually right when I got into HDR. And it was I went from thesis at North Dakota State University, doing some first touches with Rhino and Grasshopper, into a project in the Middle East that was in conceptual design in Qatar. And it hasn't gone past design development, unfortunately, but we're going to explore all the different things that I was working on during that project. And so it was a really big team. We had between 15 20 people. Argelia was on this. We had people in multiple different offices from Los Angeles, from medical planning. I was on a cord shell team with 3 different designers, and we all took a different approach. I was looking at Rhino Grasshopper, one guy was focusing on SketchUp, one guy was using nothing but Revit, and in some ways we had a little internal design competition sort of every 2 days. So when you're the new guy, how do you make an impact and see what you can do with your designs? So this is just kind of a general view of the project. See if I can point. It was an expansion, so it's 3 towers. It's about 500,000 square feet, and an ambulatory on the bottom. And it's really, really big scale, much bigger than typical projects you see out here. And just looking at the master plan, the light pink on the right is the existing, very traditional. On the left is our expansion. And my effort kind of focused on the facade studies around this, which would be a very prominent view across the bay, and also the canopy entry, lots of iterations. But, and so the focus here, I won't go too much into detail. I mean, there's hundreds and thousands of PowerPoint slides going on, but just kind of focused it into the key aspects for parametric design. So what we did for the massing is we sort of shortened the south facade and the east facade. Even though it's still rectilinear, it's kind of offset to a rhomboid. And then that gave us a little bit of massing criteria because the true south was from here. And then, then from there, we respected the medical planners and said, okay, we're gonna create a shading device on the outside of that, and we'll respect whatever you guys want to do internally. And then that gave enough of a back and forth dialogue for us to find opportunities, kind of like at the knuckles here where they were breaking. So that's just kind of the general mass. And again, just lots of planning going on, patient towers, and you know, in healthcare, it's extremely function-driven. Walking distances are huge, and so didn't want to, ruffle any feathers in that respect. So the approach that I ended up taking, there's a lot of different things we started to think about, but key tenets. I don't know if you can read all these words, but we've got flexibility in the upper left, constructability. Obviously, it has to be built. Design things like rhythm, tying into performance. It's extremely hot out there, 120 degrees, in the summer times or more. The cultural rich patterns of the Arabic people, how we deal with light and shade, and how we actually create a compelling design that respects the old, but also moves into the 21st century. So thinking in terms of the approach from specifics, right? That's like nice and fluffy and we like that, okay, great. But how do we actually execute? right? And I'm painting this, facade studies tend to be common, more or less, in terms of how we apply computation. At the back end, I'll discuss just some opportunities once we get our head around what's going on. So just made some key anchor constraints. We're gonna do prefabricated. We're gonna, again, clear designation of scope between healthcare planning and core and shell. We wanted to have minimal user input from the designer to make updates, so change management was a big thing. Because of the scale, I basically built a single curve that would outline any changes that might come from Revit, and then the entire facade system would update as a result. So it was basically two curves and 2 points that would deal with the knuckles and the profile. And then I could simply draw a new curve on the north side, rerun the script, and in 30 minutes we could just update our design. And then obviously the aesthetics was a big piece, so how does that fold into this functional priority? Okay, so here's kind of the approach. The inspiration came from the local sand dunes, but the word wadi is also, it's like the estuary that goes out to the Arabian Gulf. So I took that as an inspiration. I really love the curves, and it's kind of contradictory to healthcare, which is very linear and box-like. And so then the very first pass, and this is like in 3 weeks, I just took this image and I actually just drew this image, black and white, in Photoshop, and just said, okay, I think this captures the essence of the design. And then utilizing Grasshopper, use that to map the black and white ingredients around the facade in a complex surface. It's not linear by any means. And then using that to actually drive how this is rotating. And so it created this really nice wave pattern that the client really started to fall in love with, and they decided to move forward with it. So this was like the first iteration, and from there we kept I kept refining the system. So some of the things that were key constraints, I worked directly with the project architect. We're in conceptual design, and I'm tapping on the shoulder saying, what is the biggest panels that the fabricator can make? And he's like picking up the phone for fabrication, and it's like conceptual design. It's like completely throwing for a loop, because I'm like, I need to know how big I can go, what's realistic, what's cost effective, and building that in from the very beginning, so that any designs I do in the algorithm, everything's a solution, and that's the big thing. So one of the constraints was setting the domain from completely closed at 0 degrees rotation up to 45 degrees. So anything that might be a full black might be 45 degrees. But then, and then letting that, you can see how it starts to rotate. And that's kind of the finished product for the first major pass. This was after about 2 months. Yeah, take that in for a second. It's fun when you send your stuff off to the rendering company and it looks really good.